L.8.4, when we're transforming quadratic functions, here's what you're going to be able to do. Here's what you need to make sure you know how to do. I can compare the graphs of quadratic functions. You're going to be comparing graphs of quadratic functions and be able to describe the transformation. Or in other words, how is this one different than that one and what caused that? Okay? So in the first part of this, it says compared to the function of f of x equals x squared. Let's circle that. Does anybody remember what that function is called? What's that one called? F of x equals x squared. It had a special role. Okay, I guess I'll have to help you out unless somebody's come up with it. It's the parent function. Okay, this is the parent function. In other words, it's the most basic quadratic function, and any other quadratic function that we have other than that one has been transformed from this one. Okay? So when we talk about the parent function and making comparisons, this is how we make our decisions. A quadratic function will become narrower or wider. So in other words, it'll get skinnier. I say skinnier because it's an easier word to say. Or wider, depending on the value of a. So I want you right now to, right here, I want you to take this, become narrower or wider depending on the value of a. I want you to box that around. A now has another role. A does not only tell us whether it opens up or down, but it also tells us how wide it's going to be, or how skinny it's going to be, compared to another quadratic function. And then the other thing the other types of transformations, there's more than the two that we're going to talk about, but we're only going to talk about these two. What does the A do to its width? And then the other transformation we're going to talk about is translating. Does anybody remember what a translation is? It's a translation. Cameron?
Moving the graph down an axis or across an axis.
Yeah. It's taking the graph and moving it either up or down or left or right. It's called a slide. So in other words, does it move up from the other one? Is it down further than the other one? We're not going to do the left or right ones. We're only going to deal with the up and down ones. So I also want you to underline that. Translate up or down depending on the value of C. So in other words, if the vertex moves, or the y-intercept moves, excuse me, C is not always the vertex. If the y-intercept moves, then if it changes, then that means it is also translated, okay? So we're going to be concentrating on A and C. There are other things. B actually plays a role also, but we don't have to study that this year. That would be something you would study in advanced algebra. What does the B value do to it? And that's even more complicated to understand. So thank goodness we get to just work with A and C. So here's the deal. If the absolute value, will you put an arrow beside that? If the absolute value of A is less than 1, notice it doesn't say less than 0, not negative, it just says if it's less than 1, if the absolute value of A is less than 1, well, absolute value has to be what? That's distance. What does it have to be? What kind of a number does it have to be for sure? Positive, because distance is only positive, or it can be 0, but in this case, A can't be 0, we wouldn't have a quadratic function. You need an A. So if it's somewhere between 0 and 1, let's put that. Between 0 and 1. If the A value, when you take its absolute value, is somewhere between 0 and 1, you know that the graph is going to get wider. It's going to get fatter. It's going to come out. If the absolute value of A is greater than 1, so that just means more than 1, anything greater than 1, and notice 1 isn't included in either of these descriptions, because what's the A value of the parent function? What is the A value of the parent function?
1/3.
No, what's the A value of the parent function? Right here. This guy. What's the A value? It's 1. So we're trying to say, how does it differ from the parent function? Well, so if it has an A value of 1, then its A value is the same. It's not going to be different. So we're talking about when that A value is different. So we have the two situations. If the absolute value of A is between 0 and 1, it's going to get wider. If the absolute value of A is more than 1, it's going to get skinnier. It's going to become more narrow. So for any change in A, notice what this says right here. Okay, put an arrow by that too. Those are two important things right there. For any change in A, the vertex and the axis of symmetry stay the same. In other words, the vertex does not move. Well, if the vertex doesn't move, folks, either does the axis of symmetry, right? So the only thing A does, we now know, plays two roles. What's one of the roles? Tells whether it what? It's wider or narrower. What else does A do? What's the other role it plays? What about the parabola? Come on, you guys. We've been talking about this for days. What did A do before today?
Up or down.
Up or down. Whether it opens up or it opens down. So now A plays two roles in our quadratic functions. It either is going to open up or it's going to open down, according to A. And then we're going to talk about, is it going to get skinnier or is it going to get wider, according to A, the absolute value of A. The vertex is not going to move. If the vertex doesn't move, either does the axis of symmetry. So A does not affect the vertex or the axis of symmetry. C, that's the other thing we're going to deal with, is our C. So if, put an arrow by that, if C is greater than 0. So in other words, if C is what?
1,
Greater than 0?
1.
Less.
What numbers are greater than 0?
1 or more.
1 or more? Well, no, how about 1/2? What about 1/3?
All round numbers.
I'll do some positive numbers, you guys. If C is greater than 0, in other words, if it's a positive number, the graph is going to move up. If it's a negative number, less than 0, that means the graph moves down. The vertex moves down. Okay, so what is the C value in the parent function? What's the C value back up there in our parent function? F of x equals x squared.
0.
0. So if we have a C value that is not 0, and it's positive, that means the vertex moved up. If we have a C value that's not 0, but it's negative, that means the vertex moved down. Will the axis of symmetry change when a vertex moves up or moves down? No, can't. It's moving up or down should not change the axis of symmetry, should it? It would have to move left or right to change the axis of symmetry. So that should not be affected. Okay, so here's just an example. They've already taken the graph. They called it g of x because that just means we have another function. So instead of f of x, we use another letter. Other than f, we say g of x. We usually talk about the transformed one in another letter. So g of x equals 1/3 x squared has been, we're going to compare it to the parent function, f of x equals x squared. What happened? Compared to the parent function, what happens with when we have g of x compared to it? Is g of x the same width? No, what happens? It's wider. Why is it wider? What's the reason again?
Because A is greater than 0.
No, because not because a is greater than 0. Why did it get wider? Why did the graph, this one, 1/3 x, this is it right here. Why did it get wider than the parent function?
Because A is less than 1.
Because a is less than 1, but greater than
0.
0. It's somewhere between 0 and 1. Is 1/3 somewhere between 0 and 1?
Yes.
Yeah, so it should get wider. Okay, and then the vertex is the same. Why does the vertex stay the same?
Because there was no C.
Did the C value change?
No.
No. It's 0 for the parent function. It's 0 for the new function. The vertex, remember the y-intercept has to move it up and down. And since the y-intercept is 0 for both of them, I shouldn't say the vertex is 0, excuse me. It actually is, but the y-intercept is 0 for both of them. So if the y-intercept does not move, either does the vertex move. So it's going to stay in the same location. Okay, let's look at this one. Compare the graph of h of x equals x squared minus 4 to the parent function. Let's look at their a values. The a value change? What's the a value for this one? 1. What's the a value for this one? 1. So is it going to be the same width? Wider? Skinnier? What's it going to be? Same. Now, don't be fooled. This is really hard. When we do graph them, here's what happens. The one that is the x squared minus 4, it looks fatter, doesn't it? But that's not. It just has more graph to cover, so it looks like it's wider, but it's really not. The a value, remember, controls the width, so it's not actually, it is not actually wider. Okay, and then, so that means the width didn't change. So now we'll look at the c. What's the c value for this one? -4. What's the c value for this one?
0.
0. So what happened? It had to move up. Is c greater than 0? No, c got less than 0, so it moves it down. So it moves it down. So the vertex, actually, the y-intercept actually moves down, which then also moves the vertex down. Okay? So in all of ours, the vertex of the parent function is always, the parent function always has a vertex at 0, 0. And so our vertex is actually always going to be the y-intercept on these, because we're not going to have b values that we have to worry about. So our vertex is always going to be on the y-axis. So we really can just consider what happens to the y-intercept. The same thing will happen to the vertex, okay? So let's go with, here's what we're going to do to get these graphs. We're going to go to put these in our graphing calculators. So go ahead, let's get your graphing calculators ready to do it. f of x equals x squared. The first one is our parent function. So here's what I want you to do. Go to the y equals screen. And anything that is in the y equals screen, clear it out right now. So get on whatever is in there and clear it out. We don't want anything in there. If any of the plots across the top are darkened, you know, like plot 1, 2, or 3, they're darkened, cursor up and get on that plot. Get arrow up and get on that plot, and press the enter key. It will turn that blackness off. It'll turn that plot off. We don't want it on. So you should have an empty y equals screen with no darkness at all across the top. Okay? Everybody got that? Next thing I want you to do then is we're going to put the parent function in. You don't have to put the f of x or the y, you just have to put the other side. So we're going to put x squared in. So the x key is next to the alpha key. And so you'll press that, and then you'll go to the x squared key and press that, and it'll square that x that you put in. So right now your screen should read y sub 1 equals x squared. So the x key is next to the alpha key, and then the x squared key is below the alpha key, I think, or 2 below it, I guess. 3 below it. Okay, so after you press the x key and get an x in there, go find the x squared key and press that, and it will put a little exponent of 2 on your x for you. Okay? So you have that one in. Now we're going to go put in y sub 2, we're going to put our g of x. So we put in the parent function. Now we're going to put in 2x squared. So you're going to do the same thing, but you're going to start with the 2 in front. So 2, and then the x key, and then the squared key, and you'll have your new function. X key is right there next to the alpha key. And then the squared key is right there. Okay, now go push down, get out of y sub 2.
So we went down to the next
Yeah, so
y.
I'm sorry, yeah, arrow down to y sub 2, put a 2 in,
Let's try 2
now
in.
your x, and then square.
So 2 in.
Oh, okay.
Great.
Now, instead of us having to be really, it's going to take a lot of time to do this, what I want you to do is I want you to press the zoom 6 key, do zoom, and then the number 6, or you can arrow down to 6 and press enter, but we're going to do a zoom 6, and it should graph it for you. Okay? So, which one, would you just draw those on your graph, just a rough sketch of them? Draw those on that graph on your paper there. Just make a rough sketch of what's showing up on your graphing calculators right now, okay? So down on your papers, just make a rough sketch of what's showing up on your papers right now. You don't have to have points, you can just have a, kind of a sketch. Okay, and then I want you to make a decision. Which parabola do you think belongs to the parent function? And which one do you think belongs to the transformed one, the g of x one? Which one do you think is which?
The first.
And then we gotta have some reasoning behind it. Okay, Brian, what do you think?
The g of x is the outer one, and the f of x is the inner one.
So you think, a second, I wanna get this just a little bit better than I did. So, red still, okay. And I'm gonna make that inner one in blue, okay. So, you think this one out here is the g of x?
Yep.
The 2x squared one? And you think this one on the inside is the f of x, the parent function, the x squared one? Okay, how many of you agree? Think that would be the same? That's your call on it. Okay, well, let's do this. Let's decide f of x. Remember, what controls the width? Because I think that's what you're basing it on, is the width right now, aren't you? Is that how you're making the decision? Okay, what controls that? The a value. Okay, so f of x equals x squared. Would you write that down, please? And g of x equals 2x squared. What's the a value for each of them? 1 for the parent function, 2 for the transformed function. Okay, now go back up in your notes and see what happens when when the absolute value of a, well, the absolute value of 1 is what? Absolute value of 1 is 1, right? Absolute value of 2 is 2. Okay, so the absolute value of 1, let's go up here and see what our choices are, is less than 1, is greater than 1. Well, that one we're going to say, remember, that parent function is always going to be 1. So we're not going to, that's our one that we don't even have to do that part, okay? We're going to do it for the other one, though. So we're going to say the absolute value of 2 is that, remember, here's our standards, is that less than 1 or greater than 1? That's greater than 1, okay. So the absolute value of 2 is greater than 1. What does that tell us then? Should it be wider or skinnier? Skinnier, Okay, so we're right now saying that g of x should be skinnier. Do we need to change our mind? Which was the skinnier one, the blue one or the red one? The blue one is. But lots of you said you think that's f of x. What is it? It's actually g of x, because this one, it says it's going to be skinnier. So I want you to go and I want you on your papers, I want you to write on your graph, I want you to show that, and put an arrow like I did, that this is actually g of x. That curve is g of x. And the outer curve is actually our f of x. So g of x ends up being the one in this, is the skinnier one. And f of x is actually the fatter one. But the parent function is actually the fatter one this time. Okay? So we're going to talk about the vertex now. Did the vertex move? Or do they have the same vertex? The same vertex. So the vertex didn't change. How come the vertex didn't change? Because the c didn't change. Okay? So let's make that note. That in both of these, c equals 0. And if c does not change, then the vertex does not change. So vertex and axis of symmetry stay the same. No, let's say are the same. Okay? Because they have the same c value. So that vertex and that axis of symmetry actually just are the same. That doesn't change. Okay. Anybody have questions on that one before we try the next one? Okay, now I want you to go into your y equals, and you don't need to take out the first one, the y sub 1, leave that one, we're going to use that one again. And then I want you to go to y sub 2, cursor down to y sub 2, and clear that one. And I want you to put in x squared plus 5. Is that good? So on your graphing calculator, just go to y equals, leave the parent function in, and y sub 2, put in the x squared plus 5. So x squared plus 5 is going in y sub 2. We're going to keep the parent function in x sub 1 or in y sub 1. And then I want you to sketch that on the graph on your paper again. You don't want the 2 there though. So why don't you cursor back on top of that 2 and just keep it just take that 2. There you go. Then you press graph. You can press graph once you get that in. Just press graph and it'll take you back to the graph and you can sketch it on your paper what it looks like. Okay? So just reproduce it to the best of, it's just a rough sketch. Okay, and then we're going to do the same thing that we did before over here. We said f of x equals x squared. What's its a value? G of x equals x squared plus 5. What's its a value?
1.
So for the parent function, it's 1. What is it for the transform function?
1.
It's also 1. So what would we say about their width? Same width, right? Okay. Oh, look at your graph. How do you feel about that? Do you think they're the same width?
Yes.
Yeah, they are, even though it's kind of deceiving. It doesn't really look like they are because the one that is up higher doesn't have as much graph to move on, so it's actually looking skinnier, but it's not. Because remember, the A controls that. So if they have the same A value, they are the same width. Okay? Well then, next thing that we decide is, what does C equal for both of them? So what does C equal? What's C equal for the parent function? 0. And what does C equal for the transform function? 5. So what happened? So the vertex moved up, okay? And I'll let you say to where, because the vertex of the parent function is always going to be 0, 0, the origin. So where did it move to? What's its ordered pair name? 0, 5, yeah, it moved up to 0, 5. Does the axis of symmetry change? No. We just moved up. So the axis of symmetry stays the same. Axis of symmetry is the same. So this is what you're going to be doing in your homework, is writing words instead of graphing. So you need to get this on your notes right now, okay? This is important that we have this to refer to in our notes to help us. Because you're going to be doing it abstractly, just looking at the equations, like we're going to do on the backside shortly. So, any questions? Rose?
So is my axis of symmetry always going to be the same even if my vertex moves?
If it moves up or it moves down, it's going to stay the same, yes. Okay. Any other questions? Okay, flip over to the back side. I don't want you playing with the driving calculators right now. In fact, I want you to do second on to turn them off for a little bit, and then we're going to use them again. We can turn them back on, okay? Because we're not going to be doing any more graphing at the moment. Okay. So the other thing we're going to compare is whether they both open the same direction or not. So notice in well, I thought we did that. A positive for both. Okay. You know what, we're just gonna go down to number 3. I'll let you study that one about on your own. So number 3, compare the graphs of g of x equals negative 2x squared minus 1. Notice on the graph, they have a graph. You know what we forgot to do on the other one? We forgot to give them names on the front side, didn't we? Let's go back and do that really quick. I'm still here, you're not, but, so which one is which here? So this one we said is the f of x or g of x? That's our g of x.
H.
Oh, h of x this time, I'm sorry, thank you, h of x. That one's our h of x. And the green one, in my case anyway, the wider one, the one that looks wider but really isn't, is our f of x. Okay, the one that's, its vertex is lower. So let's make sure that when we look at our notes, we're clear on that. Okay, now let's go to the back side again, and then number 3. Says compare the graphs of g of x equals negative 2x squared minus 1. Which graph is it on there? The dashed one or the solid one? The solid one. G of x, they've shown you that. And f of x, the parent function, equals x squared. That's our dashed one. Okay, we're going to compare them. Okay, but before we do that, here's what we're going to do. We're going to, underneath each of them, we're going to say what is its a value, what is its c value. Okay, a, c. So what's the a value for our g of x function? Negative 2. What is it for our parent function?
X, or
1. What's our c value for our g of x function?
1, negative 1.
Negative 1. What's our c value for the parent function?
0.
0. Okay? So when it says compare, we're going to talk about all the things they have in common that are the same and what are the things that are different. So let's start with their opening, because we haven't done that yet. We're going to use the a value. The a value tells us 2 things. Do they both open the same way? No, they open opposite directions. So let's, because the a value, we're going to be able to do this abstractly. They open opposite directions. And our reason is because one of them has a negative a, the other one has a positive a. So one's going to open up and the other one's going to open down. A controls what direction they open. Okay, that's one of our comparisons. Now we're going to do the other thing that A does. We're going to compare their widths. Are they the same width? Then let's compare g of x to f of x then. Is g of x wider or skinnier than f of x? Okay, because, let's do this, absolute value of negative 2 is what? What is the absolute value of negative 2? 2. And is 2, remember we compare it to 1. What relationship does it have to 1?
It's larger.
It's larger than 1. What happens when a gets bigger than 1?
It's
Does it get wider or skinnier? It's skinnier. Yeah, it kind of seems the reverse of what it would. You think the bigger it gets, the wider it would open. But it's the reverse of that. It actually makes it more narrow. So we're going to say that g of x is skinnier, I like to use that word, I don't know why, than f of x. G of x is skinnier or more narrow, or you can use the word narrower, which is hard to say, than f of x. Okay, that takes care of our a value, the 2 things that we look for with our a. Now our c value. What's true about our c value? Are they the same? Okay, so that means the vertex didn't stay in the same spot. What did it do? Okay, so g of x vertex is down 1. And so what is that ordered pair name? 0, negative 1. So the g of x vertex moved down from the f of x one, it moved down 1. So we have it, instead of being at 0, 0, it's at 0, negative 1. Okay, so the vertex moved. The only other thing we compare is the axis of symmetry. What's true about the axis of symmetry? Did that change?
No.
No. So we're going to say axis of symmetry stays the same. And the reason the axis of symmetry doesn't change is because we didn't move left or right, we just moved the vertex up or down. Moving it up or down just moves it along the axis of symmetry, it doesn't move it off of it, it doesn't move that axis of symmetry. So axis of symmetry stays the same. Okay, so now we're going to do 4 and 5 without a graph. Okay, and then we can verify it with our graphing calculator if we think we have time here. So g of number 4. G of x equals 1/4 x squared, and f of x equals x squared. What did I say is the first thing we're going to do? Identify the a and the c. Okay, so our a value for this one, and our c value for this one, and our a value for this one, and our c value for that one. So go ahead and get those identified. Okay. So, see the two things we do with the a value. The two things we do with the a value are direction they open. Do they open the same or do they open opposite? What do they do? They open the same direction. Okay, so our first comparison is open. Oh, here, let's do this. Both open what? What direction?
Up.
Up. Okay, let's write it that way. Both open up.
And notice how she's numbering those?
Because you should have 4 for every one of these, okay? A is going to tell us 2 things, C is going to really tell us 2 things. Okay. So, the A tells us we're going to compare how they open. And what's the second thing A tells us?
That F is green.
It's so we're gonna talk about it always in G of X terms though. G of X is wider or skinnier?
G more skinnier.
Okay, why is it skinnier?
Because
Ooh,
the
Let's do our thing. The absolute value of 1/4, what is that? 1/4. We're going to compare 1/4 to 1. What's true about it? Is less than 1. So there's our support for whatever we decide. Is it skinnier, wider, or the same? It's wider. Go in the front and look. When A is between 0 and 1, it is wider. And this is between 0 and 1. 1/4 is between 0 and 1. So G of X is wider. I'm not making you write a whole lot of words, but you gotta say enough here and show enough support for it. Number 3. Now we're going to move on to our C. The C value tells us whether the vertex moved or not. Did the vertex move?
Yes.
What did it do? What direction did it move? And how many units? Okay, vertex. Oh, we gotta say G of X in front of that. We always gotta talk about which one we're talking about. G of X, vertex, moved up 4. Because the C value changed from 0 to 4. It's greater than 0. It's a positive number. So it moves however many units that positive number is, or negative. But in this case, it's a positive 4, so it moves up 4. So the vertex is now, what's its name? 0, 4. So it moved up. So you should be able to visualize this other graph right now. Here's the parent functioning opening up. Here's the other one's opening up. But the other one is wider. And it did what? Moved up 4 units. And did the axis of symmetry change? No, axis of symmetry, number 4, stays the same. And you might get tired of writing that. You're going to be like, that's what we say every time. Well, we got to get it planted in our head that it does not change when it moves up or down. Okay, if we had time, we put this other graphic calculator, but we're running out. Trey.
Can we abbreviate that to AOS?
No, we're not texting here, or we're still, you know, we still have words in our vocabulary, believe it or not. Okay, let's go on to the next one quickly here. A equals, C equals, A equals, C equals. That parent function's a no-brainer, isn't it? What's A and C for parent function always? 1 and 0. Okay, what's our A for the G, or the H of X this time?
-5 and
-5 and -1 for C. Okay, number 1.
Open opposite.
Open opposite directions, okay? Okay, so they open up their opposite direction. And then the A also tells us, okay, our absolute value of -5, what is that?
5.
+5, write that down. Absolute value of -5 is +5.
And 5.
Then the next thing we do is we compare that to 1. What relationship does 5 have to 1?
That's great.
Is greater than. So that tells us what?
That it opens wider.
Okay, so we're really on number 2 here. I'm kind of doing the work for number 2. So we're going to say that H of X is wider? Skinnier, because remember when the A value's absolute value is greater than 1, it gets skinnier, not wider. Okay, and then number 3, now we start with the C value. Brighton?
Isn't it -5?
No, because we take the absolute value of -5 and it becomes +5, so we actually compare that. Because if we compared it as it's negative, then it'd be less than 1, wouldn't it? Then we would think it was wider. So we have to compare its absolute value. Okay? Okay, so what's happened to the vertex? So the vertex does what? Or H of X, vertex, goes down 1. Okay. So what is its vertex then? 0, -1. If we did put this on the graphing calculator, that's where we would see our vertex at. 0, -1. And number 4, axis of symmetry stays the same. You guys are going to be so good at spelling axis and so good at spelling symmetry. You already knew how to spell stays the same. I know you did. And we're not using abbreviations. Okay, we're gonna, practice our handwriting skills also, along with our math skills. So any questions? Okay, then here's your worksheet that you'll be doing. Yes, Will.
Are we not doing the opposite of it?
We're taking the absolute value of them, whether they're a fraction or an integer. We take its absolute value and then we compare it that way. Okay? So we took the absolute value of 1/4 here in this one, and we said the absolute value of 1/4 is 1/4. And then we compared it to 1. This is what we compared. Okay? Okay, anybody else have any questions that haven't gotten answered? That you're still unclear about? Cameron?
We need those.
Do you need loose leaf? I think you should be able to do it on here. You can try. If you're somebody who has big font, you might want loose leaf. But otherwise, I think you might be able to do that here. Emerson?
Oh, sorry.
Okay. And wrapping calculators, I want you to just keep them, and then when you go back to, if you don't have a phone back there, you can go to return yours now. That'll take care of some of you. And then those of you who have a phone, you'll wait. And you'll just take yours back when you go to pick up your phone. Okay? There's the people who don't have a phone back there first. So you put that on the recorder.
Oh, I'm sorry. Did I goof everything up now?
There, and then that little button. Oh, did you? Oh, yeah, I think yes. Stop it.
I'm sorry. Should I stop it?